Hello everyone, myself Sahana HP, studying Computer Science and Engineering in SVCE. My library ID is 23CS1812. Subject is Applied Physics. Today I am going to explain about the topic Heisenberg uncertainty principle and its applications. The Heisenberg uncertainty principle is a fundamental concept in quantum mechanics formulated by a German physicist Werner Heisenberg in 1927. Heisenberg uncertainty principle states that it is impossible to simultaneously and precisely know certain pairs of physical properties of a particle such as its position and momentum, and its mathematical formula of this principle is delta x into delta p is greater than or equal to h divided by 2, where delta x is the uncertainty in position, delta p is the uncertainty in momentum, h is the reduced Planck's constant, that is h is equal to h divided by 2 pi. Next, greater than or equal to denotes that the uncertainty relations. And next we will know about the physical significance of Heisenberg uncertainty principle. According to the principle, one should not think of exact position or an accurate value of momentum of the particle. Instead, one should think of probability of finding the particle at a certain position or the probable value of the momentum of the particle. Moving on to the explanation of uncertainty principle, in microscopic systems, certain variables are interlinked with each other. If the value of one variable changes, leading to a change in the value of other variable, these variables are known as canonical variables. For microscopic particles, we cannot determine the exact values of these variables. In turn, we can determine their values in terms of probabilities. The estimation of such probability are made by density function in quantum mechanics. Applications of Heisenberg uncertainty principle. There are many applications in Heisenberg uncertainty principle. First one is electron cannot reside inside the nucleus. From deriving the equation, we conclude that minimum energy of electron released during beta decay should be 9.3 megavolt. If the electron reside inside the nucleus, experimental value reveals that the electron energy during beta decay is of the order of 3 to 4 megavolt. Hence, electrons cannot reside inside the nucleus. And the next one is position and momentum uncertainty. The more precisely you know the position of the particle, that is delta x is small, the less precisely you know its momentum, that is delta s is large, and vice versa. Next one is fundamental limitation. The Heisenberg uncertainty principle is not a result of experimental limitation, but it is a fundamental property of quantum system. It arises due to a wave-particle duality inherent in quantum mechanics. And the next is wave-particle duality. Particles such as electrons exhibit both particle-like and wave-like properties. The uncertainty principle reflects the limitation in simultaneously measuring conjugate variables, reinforcing the wave-particle duality concept. Next is quantum fluctuations. The principle is related to inherent fluctuations in quantum system. Even in a vacuum, particles can never be completely at rest. They undergo fluctuation in position and momentum. Applications is applications in technology. The principle has practical implications in technology such as limitations on the precision of certain measurements, and it plays a role in the design and understanding of electronic device at the quantum level. Next is limitations and measurements. The Heisenberg uncertainty principle places a fundamental limit on the precision of measurement. It implies that there are inherent uncertainties in our knowledge of certain pairs of conjugate variables. Moving on to the next slide. This quantum information and computing. The uncertainty principle is a crucial factor in quantum information theory and quantum computing. Quantum computers leverage quantum superposition and entanglement, which are rooted in the principles of quantum mechanics, including the uncertainty principle. And the last applications of Heisenberg uncertainty principle is energy and time uncertainty. The Heisenberg uncertainty principle can be extended to other pairs of the conjugate variables such as energy and time. It implies that the more precisely you know the energy of a system, the less precisely you know the time it took for the measurement. And the conclusion. In conclusion, Heisenberg uncertainty principle is a foundational concept in quantum mechanics that fundamentally changes our understanding of behavior of particles at the quantum level. The principle asserts that there are intrinsic limits to the precision with which certain pairs of complementary physical properties such as position and momentum can be simultaneously known. The more precisely on the property is known, the less precisely the other can be determined. Heisenberg's uncertainty principle revolutionized our understanding of the microscopic world and introduced a level of inherent unpredictability. While it poses challenges to classical intuition, it also opens up new avenues for explanation and application in emerging fields such as quantum computing and technology. The uncertainty principle stands as a testament to unique and often counterintuitive nature of quantum mechanics shaping the landscape of modern physics. These are the applications of Heisenberg uncertainty principles. Thank you everyone for watching the video.